So in this question, we have two figure skaters moving together over ice with negligible friction, as shown above. So here is their location at t0. There's their time at 2 seconds later. So we might infer then that their position here was t equals 1 second. Skater 1 with the red black dot is twice as massive. So if we give this little one m, this is 2m. So they push off with each other. So what happens here is an explosion. So now we're talking about conservation of momentum. So the location of skater 1 is shown at 4 seconds. Skater 2 is located at which of the labeled points. So with this system, it's important to know that this is governed by the law of conservation momentum, which says the initial momentum of the system before an event will be equal to its momentum after the event. And by this, we're also talking about the center of mass of the system. So we can see that this center of mass in 1 second moves 2 units. Center of mass moved 2 units. So the center of mass is going to continue moving 2 units every second. So the center of mass, if we draw it, will be here, and at 1 second there, at 2 seconds there, at 3 seconds there, 4 seconds there will be the center of mass of this system. So skater 1, which is twice as massive. This is where skater 1 is. Where will skater 2 be for the center of mass to be located here? Now, if skater 1 and skater 2 had equal masses, the center of mass at time 4 is located here, and skater 1 is here, and skater 2 would be here. That's if they had the same mass. And of course, you could see that if we're located at B, the center of mass would be here. So that tells us that A is out as a choice, because that's where the center of mass is. B is out as a choice. C would be if they had equal mass. And now if you notice, D is twice as far away. D is twice as far away. So the center of mass is located at this location A for D. So we are looking at choice D. Now, we could do this by center of mass. We could also go through and do a detailed calculation of this. So we could say the momentum initially will equal the momentum afterward. And initially, we had 3m with a velocity v. And that velocity was, let's say, 2 units per second. And each second, it was traveling 2 units. So we have 6m is the momentum before. Afterward, we have the mass of skater, or the momentum of skater 1 plus the momentum of skater 2. And so this is 2m, and its velocity was 2 units per second. Its velocity was 2 units per second. Oh, excuse me, it's not 2 units per second, because it took 2 seconds to go 2 units. So its velocity is 1 unit, and the other one has a mass of 1. So what would its velocity be? Well, we have 6m equals 2m plus mv. So that gives us 4m equals mv. Dividing both sides by m, we're left with v equals 4. So if it traveled 4 units per second, it would go 1, 2, 3, 4. And the second, 1, 2, 3, 4. So So there are two discrete ways to solve this problem, one conceptually and one mathematically.